All right, we're going to go over how to balance reactions in a nutshell. So these are chemical equations that are unbalanced. Now, what does unbalanced mean? It means that you don't have the same number of elements on both sides. And this basically supports the conservation of mass law in chemistry, which basically means that you have to have the same amounts of reactants as you do products, which if we extrapolate, that means that we have to have the same mass of each element before and after the reaction. So you can't lose mass. You can't gain it, you can't lose it. It's just there. So let's take a look at this to see if these are balanced or not. So the first one, we have 1K on the left side. We have 3Ks on the right side. So you can see right off the bat, the K is not balanced. All right, let's take a look at your hydrogens next. You have 1 hydrogen here plus 3. You have to add the number of each element in all the compounds and total them up. So 1 plus 3 gives me 4 hydrogens. All right, on this side, I have 2 hydrogens. So I'm going to put 2 hydrogens here. And that just comes from here. All right, next, let's look at our P's. How many P's do we have on the left side? We have 1 P on the left side. So we're going to fix that, or not fix it, but to make note of it. So you have 1 P on this side, and on this side, we also have 1 P. We have 4 plus 1. That's 5 oxygens on the right side. How many do we have on the left side? We have 1 plus 1, 5. So that one's actually balanced. We're going to call it oxy so it doesn't look like 50. So 1K versus 3, that's not balanced. 4H versus 2, that's not balanced. 1P versus 1P, that's balanced. And 5 oxygens versus 5 oxygens, that is balanced. So there's some elements that aren't, some that are. Let's take a look at the next one to see if we could identify what's balanced or not here. So let's start with Fe. We have 1 Fe. We have 1 Fe. Chlorine, we have 3 chlorines here. And on the right side, we just have 1. No subscripts, you assume it's a 1. For our nitrogen, we have 1 on this side, 1N. On this side, 1N as well, so 1 nitrogen. Now comes the more difficult hydrogen one, because you have to add them together. 4 plus 1, that's 5 hydrogens. On this side, 3 plus 4, 7 hydrogens. And finally, our O's. 1 O, so 1 oxygen. Let's make our H looks a little cleaner. And then you have 3. So it distributes. For the oxygen, just like the hydrogen distributes. So in case you didn't notice that earlier, you had 4 H's. And if you distributed 3 to both the O and the H, that means we have 3 H's here. So the 3 plus 4 is what it gave us, our 7 hydrogens. Same way, our oxygens, 3 times 1, so 3 oxygens. Oxygen. All right, so that's how you identify what's balanced or not. You just distribute when there's a parentheses, and then the subscripts becomes the number of that element. So let's go into how do you balance equations. So there's 4 steps. The first thing I want to do is count the number of atoms on both sides. There's a polyatomic ion treats as a single unit if it doesn't react, which basically means if you have PO4 on both sides, treat it as PO4 instead of as P and O. Don't do it separate, do it together, and I'll show you what that looks like in a second. 2, use coefficients to balance elements one at a time. You can only place numbers in front of compounds. You can't put in between, you can't do the subscript. So the only thing you're allowed is to put numbers in front of the chemicals. 3, balance alphabetically, one element at a time, but do H and O last. It just works out that way. You leave H and O for last, and I mean that sequence too. So you do H and then you do O as your final element. It just makes it a lot easier, and you'll see in a lot of times it actually helps you get the answer faster. And lastly, if you have an odd number of an element on one side of an arrow and even number on the other side, we're going to double the odd side. And we'll see what that looks like in a second as well. So let's look at a reaction and apply all these rules. So we're going to balance alphabetically. So alphabetically means that Cl, which is lowest in the alphabet, can go first. So I have 2 chlorines on this side, so I'm going to balance that. How? Put a 2 in front of this. When I do that, do I care what happens to the Na? No, I don't. I'll deal with it when I get to it. The important thing about this method is that you don't get bogged down over analyzing. So once you finish with chlorine, move on to the next letter in the alphabet, which just so happens to be magnesium. You have 3 magnesiums on the left, so I'm going to fix that on the right by putting a 3 in front of this. So when I did that, you see I got myself 6 chlorines. So instead of having 2 chlorines, now I have 6. So I'm going to go back and fix this real quick. So instead of 2, I'm going to put a 6 in front of this. All right, next comes Na. Na, there's 3 on this side, but I'm supposed to have 6. So 2 times 3 is 6. So my Na gets fixed. I have 2 PO4s. Notice PO4. I don't separate it into O's and P's. Just keep it as PO4. 2 PO4s on the left. Oh, look and behold, 2 PO4s on the right. They're balanced. By balancing the NAs, I balance the PO4 simultaneously. So that's my correct balance reaction. The same number of elements on either side. And if you want to verify one more time, 6 chlorines, 3 times 2 is 6. 6 chlorines, 6 times 1, because there's no subscript, you assume it's a 1. 6 chlorines on this side, 6 NAs, 2 times 3, 6 NAs, 3 MGs, 3 MGs, 2 PO4s, 2 PO4s. The 2 distributes to everything inside the compound. All right, the last scenario where you have to double the outside, this doesn't really apply to this one, so what we're going to do is look at the one where that does apply. So let's take a look at this. So if you do it alphabetically like we did a minute ago, N goes first. So the N is fine, 2 and 2. There's your problem. 5 O's on the right side, 2 on the left side. So how do we fix that? Double the outside. Just put a 2 in front of it. I don't care what happens to you, I'll fix that in a second. So that gives me 10 oxygens. So how do I get 10 oxygens? Put a 5. That gets balanced. I have 4 nitrogens. So how do I fix that here? 2. And from here on out, to make it easier for us to check our answers, we're going to put the coefficients as our answer. So 2, 5, 2. This is so we could go through the answer a little faster. All I did was take my coefficients and just write them in the sequence that you found in the reactions. So there's my answer, 2, 5, 2. All right, so let's look at some more examples. So it's a little bit more difficult. You have a lot going on in this situation. So let's start with the carbons. So, because that's alphabetically the first one, right? So 6 carbons, done. Do I care what happens to the O? No, deal with it later. There's nothing else but H and O. So what order do we do it? We do H and then O. So I have a total of 12 hydrogens. So let's fix that. 6 times 2, 12 hydrogens. I'm done, at least with the hydrogens. Now my oxygens, 6 plus 6, that's 12 oxygens. I already have 6 on this side from this chemical. So I need to make this to total up to 6. How do I do that? Put a 3. 3 times 2 is 6. So now everything is balanced. So what would my answer be for this? 1, 3, 6, 6. All right, let's look at another one. Alphabetically again, we start with SN, even though S is way after O and H. We do it first because H and O are last, right? So 1 SN, 1 SN. All right, and then we do hydrogens. We have 4 on this side. We only have 2 here. So put a 2 in front of it. 2 times 2 is 4. 4 hydrogens, we're done. Remember, the 4 distributes to everything inside the chemical or the compound, sorry. So 4 H's and 4 O's. Now here, how many do we have? We have 2 oxygens here, plus 2 more, that's 4. And if you distribute the 4, 4 times 1 is 4. So same number of oxygens on both sides, so we're done. So your answer turns out to be 1, 1, 2. All right, next one. What do we start with? Bismuth. 2 over here, so let's fix that. 2. What's next alphabetically? Nitrogen. Now, NO3 is on both sides, so I'm going to treat it like a polyatomic ion and treat it as a unit. So instead of N and O separately, I'm going to just say there's 2 times 3, 6 nitrates. Remember, distribution. This number distributes all the way across. So there's 2 BIs, 2 times 3, 6 nitrates. So how do I fix it over here? 6 nitrates. We have 6 hydrogens over here. So how do we fix it? Well, actually, we should hold off on hydrogen because that should be one of our last ones. S. We have 3 S's here, 3 S's here. And you notice by doing the S's, you've actually fixed the hydrogen simultaneously. 3 times 2 is just 6 hydrogens. 6 hydrogens. We're done. So our answer was 2, 3, 1, 6. So by doing it in the sequence we did, we actually were able to balance the hydrogens without even touching them because we're focusing on the S, and by balancing the S, we fixed the H's. All right, next one, aluminum hydroxide. We have aluminum, one over here, so that's fine. Bromine, 3. Let's fix that, 3 bromines. All right, next we have H and NO. We have 3 H's here, plus 3 more. That's 6 H's. So how do we get 6 over here? Put a 3 in front of this. 3 times 2 is 6. So our H's are balanced, now our O's. How many O's do we have? 3 times 1, 3 O's. Here, 3 times 1, 3 O's. We're balanced. So our answer was 1, 3, 1, 3. All right, if you want more help with balancing, all you have to do is look at the other video on balancing reactions, which goes in a lot more detail than this. And then you will hopefully by the end of that have a better grasp of balancing.